Based on your own experience in space, do you or any of you feel that there will ever be an opportunity for a woman to become an astronaut in our space program?
I sure hope so.
We remember the moon landing as one small step for man, one giant leap for mankind. But what about the women who made it happen? Have their stories been completely lost in history, or were they completely left out of the picture? Despite a woman, Margaret Hamilton, developing the software which actually took Apollo 11 to the moon, they were in the background for much of the historical event. But that didn't stop millions of young girls all over the world being inspired to think about their future in space.
I'm a musician. I was a singer for most of my life. I still am. And I'm a very creative person. I came from a family of artists. I've always loved space. And even I, for a while, thought, what does it have to do with me? I'm an artist. There seems to be this idea that you have to be really good at math. You have to be really good at science. But I have to tell you, I took the minimum of math and science. But what I found very quickly is there's a place for someone like me.
My career has been in real estate and business, and I'm the founder of Space Kids Global. I started Space Kids Global in March of 2015, and our mission is to get students, elementary students, excited about STEAM education, but particularly focusing on empowering young girls. Our goal is to go and reach 1 million students around the world. It's exciting times to be in the space industry, with major private space companies racing to get civilians into space, which is commonly called the Galactic Gold Rush. It's an exciting time.
Goal setting, right? We set goals we don't think we can accomplish. I remember calling my parents and telling them I had an internship at John F. Kennedy Space Center, and one of the first things my mom said was, "Do you just put things on a board and throw a dart? How did you end up at NASA?" I'm a civil engineer and construction manager for John F. Kennedy Space Center. I work on projects such as the Vehicle Assembly Building, Launch Complex 39B, which is a historic complex that Shuttle and Apollo launched off of. I'm working new launch complexes. I also do roads, culverts, bridges, and office buildings. I remember walking into one of my first very technical courses at UTSA, and I think I asked the guy behind me for a pencil. And he turned to me and he said, "Here's a pencil, but you're not gonna need it anyway. Women aren't civil engineers." And I took that as the ultimate challenge. So not only did I set the curve on every single exam in that class, I made perfect hundreds on 2 out of 4. But I've always used that as a drive to do more, to be more, and to make sure I don't lose myself.
The space industry has made massive strides to become more inclusive since the 60s. NASA has now more than 10,000 female staff. However, the percentage of women working at NASA is a shocking 21.8%.
I think that, unfortunately, it's been predominated by men, but I think that just has to do with stereotypes of over time and what women were expected or not expected to do. So when you have pioneers like Joanne Morgan, who's a very important woman in aerospace. She was the only woman in mission control at Kennedy Space Center when Apollo 11 went to the moon. And she told me recently that when she graduated from school, she was only one of 5 women who graduated with an engineering degree. And so women who are that bold, that willing to not let anything stop them and do what they really, really want to do with their life, I think that's important to lead the way for young women, young girls, to understand that they don't have to be what society expects them to be. They really can pursue whatever it is that they want to do, especially if it's something that they feel they're really, really good at.
We've got examples like Katherine Johnson, who is the mathematician there at NASA, and John Glenn would not go up until she did the manual calculations to confirm the computer calculations. There's my favorite, Commander Peggy Whitson. She's not only commanded the ISS once, but twice, and holds the longest record of a NASA astronaut in space. Mae Jemison, who was the first African-American female astronaut. So I think we have a presence there. I just think it's more important that we start focusing and getting young people involved in this. Today, in the US alone, there's over 3 million vacancies in STEAM education. The universities now are only graduating 300,000 students in engineering. So this is a real problem we need to address. I think the children of today need to be encouraged to fulfill the needs of the future.
You can absolutely do this. There's going to be hard moments. There are going to be tears, likely, and there are going to be challenges that you think that you can't overcome, and you absolutely can.
I've gone to the UAE Space Agency in the Arab Emirates, Abu Dhabi, and in Dubai. And what was really, really shocking to me, actually, is that they said they're about 50% women and men in engineering. I asked them, how did you do this? And they said, isn't it like this everywhere? And I said, no, not even close.
There is a place for you at NASA, at Lockheed Martin, at Northrop Grumman, at the European Space Agency, at the Japanese Space Agency. All of these companies and these government organizations are embracing diversity because it works, because we are important parts of every team. We bring something different to the table. We're not sending astronauts, male astronauts, to the moon, to the International Space Station, to Mars. We're sending people. We're sending humanity.
I think women come together and give a different perspective. And I think we need to start thinking of these adventures as humans and not separating them by gender.
There are a lot of people who love space. You don't have to just be a scientist or an engineer, or you don't even have to want to be an astronaut. There's a lot of cool ways that you can be involved. And so one of my missions is try to make people understand, especially young girls, look, there's a place for you. There's a way that you can contribute. You can do something artistic. You can be a graphic artist. You can do music for that's inspired by space. I meet a lot of graphic designers or special effects people. And one thing that I've realized when everybody talks to me about space or about the moon landing, it's just something that we all share naturally as children. We dream, we look up at the sky, we look up at the moon and the stars, and it's something we can all relate to. We all share that same moon, regardless of your age or your gender or your economic status or your color or your location. No matter who you are in this world, every person who has ever lived, who will ever live, looks at that same moon, looks up at those same stars. And so I think that's something space-wise that's super, super valuable to make people understand. Space is for everybody.
Our astronaut corps today is extremely diverse and highly qualified. In the 1960s, we had a great moment in American history. And at the time, it was driven by fighter pilots and test pilots. And there were no opportunities for women in those days. Well, I have an 11-year-old daughter. And I want her to see herself as having every opportunity that I had when I was growing up. And because we have had such great work over the years from NASA, we now have a very diverse and a highly qualified astronaut corps. So when we go back to the moon in this sustainable architecture in the Artemis program as part of this Artemis generation, this time when we go to the moon, all of America will be able to see themselves as having these exceptionally unique opportunities. The goal here is to inspire the next generation and to bring all of America along with us in our sustainable return to the moon with an eye for the horizon goal, which is to go on to Mars.
T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, main engine start, 0, and liftoff of the Delta rocket with Opportunity, a chance to explore and unlock the secrets of our neighboring planet.
The transients at liftoff.
For Spirit and Opportunity, the mantra was follow the water. We were really interested in finding evidence that there was once liquid water on the surface of Mars. We thought there had been based on our orbital data, but we hadn't proven it. You can't prove it until you actually can get down and get your nose in the dirt. So with those rovers, we proved that, and now we've been able to move beyond that. So now instead of just following the water, what we're doing is we're trying to understand what was the chemistry of the water? How long did that water persist? Was that water something that could have given rise to life? Why did the environment change so much on Mars that we once had liquid water and we don't anymore?
You know, we want to get to Mars. We're not done yet. The job is certainly not done yet. This is the test, the last test that we can do, the last flight test that we can do on Earth. But really, our job isn't done until we see the same test flight being performed at Mars. So next time we fly, it'll be at Mars. But that's our ultimate goal. That's when we'll go, yes. It's a huge milestone for us. To have built this Mars helicopter that's to the quality that's needed to be launched, to travel to Mars on board the Mars 2020 rover, and to have met the really stringent mass constraint, coming under 2 kilograms. In fact, we weighed in under 1.8 kilograms. We have to be light to fly at Mars. We built the Mars helicopter, the helicopter that'll go to Mars. And at this time, we've shown that it can fly. We've done the flight test in the chamber with the thin atmosphere representative of Mars. Very important. And secondly, we've tested it through the thermal environment. The environment at Mars, it gets very cold at night, down to like -°C. That's like temperature of dry ice. And we have cycled the temperature on this helicopter, cycled the extreme temperatures that it's going to see. And very importantly, we've shown that it can survive autonomously.
So when we send Mars 2020 to Mars in 2020, of course, it's not only going to have the rover, it's also going to have attached to the rover a helicopter that Mimi has been involved in developing now for many years, as a matter of fact.
Over 4 years?
Over 4 years.
4.5 years. Yeah.
So tell me, how did this come to your mind as an idea? Was it out there before? Was it your brainchild? How did this come into being?
No, feasibility of helicopters flying at Mars have been proven in the in the 90s.
Okay.
In fact, Bob Belleram, who's the chief engineer on our project, he had done research in those days showing that it's feasible, it's possible. There's enough atmosphere to fly a helicopter. The challenge, of course, is it has to be very light.
Yeah.
Similarly, over in Ames, Larry Young has some research that have been proven.
Okay.
But the thing that had not made it possible until recently is the availability of technologies for these lightweight, capable flying vehicles.
Okay.
So around 2012 or so, our previous director, Charles Alachi, was on a lab tour, and he was seeing these drones being used to demonstrate autonomous navigation algorithms. And after the tour, he said, hey, why don't we do this at Mars?
Wow.
And so we connected him back. In fact, I happened to be on the bus in his tour because he was visiting our division, Autonomous Systems Division, and I was the Deputy Division's manager of Autonomous Systems Division at the time. Anyway, so why don't we do this? So we connected him back to Bob Belleram, who had done research in the 90s, and then he started from there.
Okay.
So
Mimi, tell me, why is it important to have a helicopter on Mars?
today we explore planets from spacecraft in orbit and rovers on the surface, but we're not using the aerial dimension to explore surfaces. So the helicopter would open doors to exploration through aerial dimension.
Yeah.
And that will help with forward reconnaissance, far ahead of rovers, or in the future, astronauts,
Right.
when astronauts are there to explore. And so forward reconnaissance is very important, and it's a new dimension. Secondly, we'll be able to get to places we simply can't get to today.
Right.
And even in the future, with rovers or even astronauts. For example, sites of these cliffs, right? Recently, there are these exposed ice scarps that have, we would have to fly there to get a sample and analyze them on landed assets, or bottom of crevices and steep volcanoes.
Yeah.
A new dimension, adding it.
Following our orders, barely off the ground. Don't know